I think generally the world is split into two camps. One that think that software development as a whole is going to be in natural language, and programming languages are a thing of the past, right? Because why do you need to speak this foreign language of the machine? It seems like a waste of time. The machine should speak my language and we'll be done with it. So that's one camp. There's another camp that says these languages exist for a reason, and the reason is reduce ambiguity and be precise on what is the expected behavior without running the program.
Hi, Eran. Welcome to the show.
Hey, thank you for having me.
Brilliant. So I think we've talked about software development and using AI for quite a lot on the show. So I think a lot of our listeners are aware that AI works really well for developing software, writing code a lot of the time, but sometimes it doesn't. So a big question to begin with is like, when can you use AI assistance and when do you want to handwrite code?
Yeah, I guess it really I'd like to talk about it in terms of the fundamental theorem of Gen AI, which is not that fundamental, but I'll lay it out anyway, which says that Gen AI makes sense when the cost of specification plus the cost of consuming the result is much, much smaller than doing the work manually, right? So it really makes sense to use any of this if the cost of explaining what you want and the cost of consuming back the result is much smaller than doing it yourself. So this is maybe too abstract, but that's the nature of fundamental theorems. Let me make it slightly more concrete here. It makes sense to use it if you can make a really quick snap judgment that what you got is what you wanted, right? And this in certain domains, this is easier than in others. Let me give you a concrete example. Like let's say I'm writing my React application, right? And I can see with my own eyes whether what I asked for is the UI I wanted, right? So I can make the snap judgment of like, I got what I wanted, right? So it makes sense to use that. If I'm writing very complicated, let's say, distributed system synchronization protocol, then it's going to be pretty hard for me to determine that what I got is really what I wanted. And therefore, I may be better off not delegating this task to the AI assistant or the AI agent. Does that make sense?
Yeah, I like that. So if it takes you a really long time to write your prompt, then that's like a big specification cost. If the output is hard to interpret or hard to work out whether it's correct or not, then that's a big sort of consumption cost. And you want those to be as small as possible. Otherwise, it's not worth it.
Yeah, and it's really it's not really about Gen AI in a sense. It's about delegation, right? It's also like I'm trying to delegate the task or like to offshore a task to another entity, whether a human or silicon, right? So I'm kind of like offshoring to silicon. And it makes sense to offshore to silicon when the boundaries of like, how do I define what I want and how do I make sure that what I got is sensible, right? So that's...
Absolutely. So maybe it's worth talking a bit more, like providing some context on, generative AI is just one tool among many different tools to help software developers write code. So can you just talk about like what's its competition? Like what are the other tools that people are using in order to automatically write code?
Oh, there's a bunch, of like AI-based solution for generating code. I think it really depends on the segment. Like, are you an enterprise user who is trying to write code in an environment in which things are highly specific and incremental, in which case you will use something like Tabnine, which is more aware of the environment you work in. Or maybe you're writing like small application, maybe you're not even in an enterprise setting, maybe you're a hobbyist or like an independent student, in which case you maybe use something that is more, let's say, prompt-based or more natural language-based, and the lower end of the complexity of the environment in which you're operating. But I think at this point, there's like an assistant for every layer in the space, right? And probably more to come, because to be honest, the promise of Gen AI is huge, but one of the areas in which this promise is already realized is software development, right? This is almost one of the most prominent areas in which you see the value of Gen AI every day. Right?
Okay, it's nice that there's a tool for like every different group of users, depending on like whether you're using an individual or an enterprise or what industry you're in. Okay, so let's talk about what you can actually do with this stuff. So is it just about having AI write code for you, or are there other things you can do with generative AI here?
AI can help you accelerate all activities across the software development lifecycle. So it is about code generation, documentation generation, test generation, code review, deployment to production. On all stages of the SDLC, you already see AI systems providing significant value and significant acceleration. Just on documentation generation, for example, something that developers really don't like to do, right? You can see a huge uplift there, and also uplift in the actual documentation being generated, or the documentation that is present in your project at the end, because previously people would just not write it, but now that AI gets like from 0 to 1, people are refining it. So that's one of the effects that you're seeing, is that maybe AI did not get it all the way through, but once the developer has a draft, they're going in refining that. So you get like high quality documentation by the collaboration of the AI providing the draft and the human refining that. And I think that's true across the entire SDLC. So you also see test generation. Maybe the AI did not actually hit the full subtlety of the test that you wanted, but it provided enough scaffolding and enough of the mocking, enough of the stuff around there for you to come in and do like the last mile and getting the full value out of the test.
Okay, so this is interesting because I think a lot of people, if you become a software developer, you enjoy writing code. And so having AI write your code was like, well, I was enjoying doing that. But some of these other things you mentioned, so code review, documentation, testing, these are things where like no one like got a job to really want to like write tests and write documentation. So having AI work on those things, that seems like a good idea. So I'd love to get into, go on.
I think also like in terms of writing of code, I think there's a lot of code that people don't like to write, right? There's a lot of boilerplate, there's a lot of repetitive code, there's a lot of convoluted code, complicated APIs that people generally do not enjoy. So having AI like automate the mundane stuff and the boring things, let you, the developer focus, software engineer focus on the creative aspects of the work, is really what the Gen AI is making possible. Right?
Yeah, I suppose if you just like writing a registration page, like login code for a web developer, it's like you've done this 1,000 times, doing it 1,001 times is not going to be like that much more interesting. So yeah, maybe outsource that repetitive code stuff. All right, but I would like to talk about some of these like code generation aspects of it. So talk me through code review. Like what's the kind of current workflow and how does it change once you've got generative AI involved?
First of all, it's important to understand that, the bottleneck right now for really getting the full benefit of Gen AI is code review. Really what we are seeing right now is that generation has already accelerated using Gen AI, right? So everybody is generating more and more code, but review has not accelerated to the same speed yet, right? So what you're effectively getting is like a distributed denial of service attack on your reviewers, because all the developers are using AI to generate, say, just for exaggeration, 10x more code, but the reviewer is not reviewing code at 10x speed, right? So if you want to leverage or get the full potential of Gen AI across the SDLC, we will need to solve the problem of accelerating the review itself, or making sure that the code we generate is of high quality to begin with. Otherwise, it is really DDoS on the reviewer, which is also your senior developer, right? So you're effectively hammering your senior resources to review AI-generated code, right? So that's one of the things that we are focusing on in Tabnine, is really solving this problem of the review. And the workflow is interesting because the question of like what is good quality code is not a platonic question, right? It does not live like in some academic sphere of like just clean code book or something like that. It varies between organizations, right? It varies even between teams because part of it is very, very specific to how we do things around here. Part of it is using the existing, say, microservices, the existing code base, existing know-how, right? And so standards, best practices. So really, the reason that experts are doing the reviews right now is because they have all this tribal knowledge in their heads, typically, right? And are reflecting that as new code comes in to be reviewed. And what we're doing in Tabnine is kind of replicating that specificity of the review by learning organization-specific rules and also allowing the human expert, to enter kind of organization-specific rules and have the AI, have Tabnine review the code according to these specific standards, right? So you get the AI code review to be specific to the org, aware of the existing code base, putting in comments, but also suggesting fixes automatically, right? So you get the full spectrum of kind of the human expert reviewer. What you want, the experience that you want to replicate is the expert code reviewer that has been a developer in the organization for a decade, right? That's the level of expertise that you want to reflect in the AI code reviewer. Knows all the code in the org, knows the best practices, knows why we stopped doing certain things, why you do it the new way, and knows how to guide you to do things the right way, not just complaining all the time without remediation.
That just seems smart that it has contextual knowledge about all the code that's been written before. But at the same time, that also terrifies me because it's like the terrible code you wrote like 2 years ago, somehow the AI is learning from that. And yeah, it's going to review things based on that. But okay, so the idea is that you've got AI that sort of knows everything about like the projects you're working on, gives you good feedback. I'm wondering whether it changes the workflow now, because my sense is that code reviews normally happen towards the end of the cycle. So a software developer builds something, then hands it over to someone else and says, take a look at this. If I'm writing a document, I can get like AI feedback on what I'm writing as I go. Things like Grammarly will give me feedback in real time. Is there a chance we can move towards real-time code review as you're writing?
Yeah, absolutely. That's part of what we're doing is shifting that code review aspect left into the IDE. The nature of the problems are not always the ones that you'd like to flag as you type the code, right? Because it's much more contextual than, say, Grammarly. Some of it, you'll be complaining all the time about code that has not been written yet, and that's quite annoying. We tried that. It's a bit too intrusive, but you do want some checkpoints in which you say, okay, I've seen enough. Let me tell you that you're wrong, right? You definitely want to do that in the IDE and not in the pull request if you can, because also the IDE is my private space and the pull request is public space, right? So I'd rather get your comments privately, right? Especially like if I get this in pull request, I would go, hey, Tabnine, if you knew this all along, why did you tell me earlier, right? Why did you wait until I push this, right? Like, tell me earlier. So definitely working on shifting that left into the IDE, absolutely.
Okay, that is cool that it comes sooner, but it's also interesting that you can't have that sort of instant feedback sometimes because some of the code you write relies on stuff you haven't written yet. Okay.
Yeah, it's a user experience question, really. I think some people would like it like more aggressive. Some people would like it to wait a bit and see like the full thing before it complains. But yeah.
And so related to this is the idea of documentation, having documentation being written for you. Now, there have been some sort of semi-automated documentation tools for a long time, but I'm hoping that generative AI gives us better tools for this. Talk me through how does it work, and how's it going to change people's approach to documenting code?
First off, it's really easy, right? You can generate docs and then click of a button and you get docs which are quite descriptive. Personally, I'm in the camp that says that documentation should say why it is something and not what the code does. I mean, the code says what the code does. I don't need more of that. But as I said, I think the real workflow is that you get like version 1 draft from the AI, and then once it exists, people say, okay, let me add that small note here that actually explains the important bit of why I did it this way. And otherwise, they would just not add that bit. So I think that the workflow changes by forcing the existence of documentation, and then humans are leaning in to make that documentation more meaningful, for the future Iran, who will come in a year and will not know why he did something that way, right? So I think that's kind of the flow that is happening in reality. Interestingly, by the way, we're seeing a lot of success with test generation, which is another aspect that people generally don't like to do. And again, when you have a click of a button that gives you a test plan that you can then implement with another click, and you can revise the plan and manipulate what's going to be generated. So you control the process. It's not like I'll generate whatever tests come to mind, right? You control the AI in what is the test plan that you'd like to implement. I think that is also quite successful. And another flow that is interesting is generating test cases as part of the pull request. So you push code, but in the background, Tabnine says like, hey, what you pushed did not have sufficient test coverage. How about I'll give you like 10 additional tests? You don't have to worry about them. They all pass, and they increase your code coverage from 40% to 80% code coverage. Take this additional PR if you'd like, and let's move on. That's another aspect.
Okay, I like that it can create a sort of test plan and then code the test to sort of fill things in. Are we just talking boilerplate tests here, though, or can it do more sophisticated things as well?
It's doing pretty sophisticated things. Again, it's not a replacement for the human writing the super sophisticated test that will cover the extra corner case, but I've seen tests that covered cases that I missed, right? So it's smarter than me, maybe for some cases. And so I think that was good enough for me. Others may be smarter, yeah.
Okay, yeah, I guess as a human, it's very easy to get bored writing tests, and then your test coverage is low just because you've couldn't be bothered to write the rest of the tests, and AI doesn't have that problem.
Yeah, no, personally, I'm not a huge fan of measuring code coverage. I'm not sure exactly. There are many academic works on whether that is meaningful or not, but definitely getting some tests and getting reasonable test coverage is a desirable property, and definitely better than having zero tests, right? So.
Absolutely. I'm wondering, because of the sort of probabilistic nature of large language models, you do have some randomness in the test that created. Do you have to start writing tests to test your test, like some sort of meta test situation?
That's a pretty interesting idea. I have not done that or seen that, but it's a pretty cool idea. Yeah.
Okay, maybe no one cares about testing that much. They just want to maybe just manually check their own tests. All right. Are there any other, I don't want to say boring, but are there sort of less fun bits of software development that AI can help out with?
Again, I think what we're seeing is any task that you can think of has assistance from AI, and soon is going to have an agentic workflow that does the majority of the work for you. The bottleneck for all this is what is the quality of, say, code that is being generated or refactored? It doesn't matter, manufactured, right? It's not just about generating code from scratch. It's also about making changes to your code base, right? Refactoring, modernizing, migrating between languages. All those tasks are tasks in which we're seeing increasing value, increasing productivity from AI. But really, the bottleneck is, what is the quality of the things that are getting generated? If I'm generating 10x more code and I do not provide any quality guarantees on what I'm generating, the fundamental question is, am I generating an asset or am I generating technical debt? Right? And this is a very specific question as well, or specific question, because it could be very nice code, but that just doesn't use the microservice that you should be using inside the org, right? And so, platonically, if you look at the code, it's great, but it's just not doing the right thing, right? And so the specificity of what does it mean to have good quality code for my setting is really important here. And for me to trust the AI, the AI has to understand my organization very deeply. And I also need some way to control it. Because what you said is really important as well. Like, let's say I have this legacy code, and the AI Tabnine understands that the way we do things around here is legacy code, right? Because that's what it has seen. But I really want to stop creating new legacy, right? I want to somehow say, from this point on, this is not the way in which we connect to Kafka, right? We do it like a different way, different microservice. So now I, the human, the expert, the architect, need a way to tell the AI, Tabnine, starting from November 1st, we're doing it this way, right? You need the phase shift. So you need the AI to know everything about your org, so it has some implicit understanding of what is good, but also B, a way for you, the architect, the expert, to say explicitly what is good, right? And enforce that moving forward. Otherwise, you'll never be able to kind of escape the Jupiter level gravity of legacy, right? We're trapped in legacy forever.
I think transforming your code, like moving to newer languages. I know there's a lot of big enterprises where there's still code running on like COBOL from like 1970 or something. And so, that transformation seems like a great idea. And I love the idea of sort of getting rid of legacy code. So talk me through, how does it work? I mean, I presume generative AI is good for translation between human language, right? Does it also work with computer languages?
Yeah, translation between languages is really an easy use case. Even translating from COBOL to Java or something like that, it is doable. I think what people don't realize is that porting an application from COBOL to Java is not about translating procedure by procedure. It is about re-architecting the application, really, right? Because it's just the concepts between a Java application and a COBOL application are different. And maybe if you're like doing this shift, you want to maybe transition from the monolith to microservices. Maybe there's a lot of stuff that you like to do as part of this migration, and not just translating, from running on COBOL runtime to running on JVM. That is not what you're trying to accomplish, right? You're trying to get a modern application that is maintainable moving forward. And that's much more than just translating procedure to procedure. I think that's the misconception that people have. So AI can help you re-architect as well. But I think we still need humans to kind of think what is the desired kind of end result of migrating the COBOL application. And AI can help you, once you decide on this kind of the overall structure, AI can help you do the micro steps of migrating procedure by procedure or stuff like that. That works wonderfully well with Tabnine or any other system.
Okay, so that's interesting that you've got high-level architectural decisions, and then you've got sort of lower level, well, this is like what the code's doing on an individual. And this leads nicely to like one of the sort of the most hyped ideas of the last couple of months, which is chain of thought reasoning. So the idea is you've got AI or generative AI that can complete multiple steps at once. Can you talk me through how is chain of thought going to change all this AI developer tooling?
Yeah, it's not about chain of thought specifically, or tree of thought, or graph of thought, or that doesn't matter. Like the general structure, it's all about the agentic workflows, like as you said, completing multiple steps, potentially having backtracking, potentially invoking tools, and both to read and write information, like sensing and transforming or manipulating. We're already seeing a lot of success in that. So we can have workflows that go from a Jira ticket to a full implementation, right? All the steps. So I've done this cute demo in Tabnine, which I have like start from Jira ticket. Doesn't matter. Implement the backend of the application, implement the front of the application, connect them, implement the database, and all of it is happening like as a single agentic flow. You don't have to worry about anything, right? So the AI does everything for you end to end. And there are other demos on the internet of similar things. So whether it's like Baby HEI or OpenHands or whatever, there are a bunch of those. And these agentic flows, provided with the right tools and the right abstractions, can really go a long way and take you end to end, either implement a Jira ticket or debug an application or translate an application, all those things are totally doable with the caveat that I started with, which is how do you guarantee the quality of what is it that you're getting? And maybe that loops back to your initial question of like, when does it make sense to use Gen AI and when it doesn't? So one aspect is really, easy to specify, easy to consume the result. But maybe another aspect is like, is this like the maintainable code that I'd like to live with for the next 5 to 10 years? Or is this just, like a side project, a POC or something like that? In which case, I don't mind doing the end-to-end flow without worrying about, how any of that is really implemented. So again, in the offshoring analogy, and I offshore this entire application because it's a POC, and I just want to see that I got it right. And then maybe I either manually refine the components that were created, or I rewrite it, or I do it with some coaching rules like Tabnine has, which force some standard and some quality on whatever is being generated.
That's interesting that we're from like chain of thought to agents, and actually it's like two sides of the same idea. It's just being able to complete multi-step tasks without having to have much human involvement.
Chain of thought is like one plan. It's called planning strategy of an agent involved. So it's a special case. Yeah.
And we've been talking for 25 minutes and we still not mentioned data once, which is giving me withdrawal symptoms. So I'm curious. So we talked about the software development workflow where like code is basically everything. I think for a lot of like data use cases, you've got much simpler, shorter data projects. I'm wondering for data analysts, data scientists, where he's doing these short projects, how are these sort of trends in generative AI changing things?
I think data science is the perfect application for Gen AI because what I care about, the code is really not the artifact that I'm after, right? The code is a means to an end to get the analysis that I want, to get either the visualization or data, whatever the projection that I want. And I couldn't care less about the code as an artifact for the most part, right? Unless I'm building some framework. But if I'm analyzing something, the code is going to mostly be discarded at the end of that small project, as you called it, right? So I think that's perfect match. Also, it's a perfect match for all sorts of visualization projects because I can make a snap judgment of like, oh yeah, this is the histogram that I wanted, or this is the curve that I wanted, or this is the analysis that I wanted. I can look at it and say, yes, this is great. Or I can very easily manipulate it with a prompt with natural language because, again, specifications are short. Results are easy to understand. Code is mostly short-lived. Perfect match on all three counts. And also, a lot of Python, which is a language that most of the models are really strong at. Right, because models are developed by researchers, so they try things in Python as well. So there's some, I think, very strong guarantees on Python being a very first-class citizen of the models in terms of ability to generate and accuracy, etc.
Absolutely. So I do like this sort of framework you have of like deciding whether or not generative AI is going to be useful. Just like, can you make that snap judgment or not? It just seemed like visualization works really well here because you can look at a picture and say, well, does this make sense or not pretty quickly?
But it works really well also on complicated use cases that you've done before because, like, I wrote this code somewhere, sometime, or something similar, and I look at the code being generated and say, yeah, that's exactly what I wanted, move on. So it's actually interesting that for experts, it may be easier to somewhat counterintuitively, for experts, Gen AI may be even more of a kind of a force multiplier in the sense that you're like, okay, I can make the snap judgment on a lot of things much faster than a junior would be able to, right?
So this is very fascinating because I think one of the sort of perennial questions over the last couple of years has been like, well, do I need to learn to code if AI can write my code for me? And you're saying that actually, if you've got those skills already to be able to make that snap judgment about like whether or not the code works well, that means AI is actually going to be even more beneficial for you.
Yeah, I think that's true from what we're seeing, and I think again in the foreseeable future, again not for all software, but some software is still going to be the combination of humans and AI, and the ability to read code really well is very important. Like read code well and understand what's going on quickly, because a lot of it's going to be generated by assistants or agents, and you, the human, will have to step in. So it's like the combination of self-driving cars and human-driven cars. You need to know how to operate in the mixed environment.
Absolutely. So, talk me through. Like, suppose you're an early stage, either developer or data scientist, or like anyone who has to write a bit of code in your job. What do you do? Is it worth pushing hard and becoming that expert in code, or do you want to work alongside the AI tools? Like, what would your career strategy be?
Yeah, I know career strategies is a big ask from, but again, I think it's inevitable, right? It's just like IDE is a tool of the trade, right? So some people swear by Emacs or by Vim, but they still have some extensions that help them, code completion or do some things that are taking them to additional productivity. And AI assistants are like inevitable part of the stack. So if you haven't done it still, I think you should. Whether you should learn programming, like be an expert in the nuances of Python or not, I don't know. I think a lot of the data science, at least, will increasingly move to a higher level of abstraction, I think. Again, I don't know how long will it take, and definitely not for all cases, but I've seen models do, or assistants do, pretty amazing things in data science from natural language alone, and I think this will just increase because, as I said, it's a sweet spot for this technology. You can make the snap judgment, it's easy to specify, and the code is generally short-lived. So this is like really the perfect spot.
Okay, so you mentioned moving to higher levels of abstraction. Can you just talk me through what that might mean?
Yeah, there are I think generally the world is split into two camps. One that think that software development as a whole is going to be in natural language, and programming languages are a thing of the past, right? Because why do you need to speak this foreign language of the machine? It seems like a waste of time. The machine should speak my language and we'll be done with it. So that's one camp. There's another camp that says these languages exist for a reason, and the reason is reduce ambiguity and be precise on what is the expected behavior without running the program, right? So if it's a visualization or UI, you can run it, pretty much see what happens. You don't need to be super accurate or specific about the spec, the code itself. You can predict what's going to happen by running it. But let's say it's something more complicated, how you, the human, are going to predict how this thing is going to behave. You need some language that describes it in a non-ambiguous way. And if it's not going to be English, because English is ambiguous, you need something more structured. So there have been like past attempts at some formal English, structured English, but at the end, they all deteriorate into some form of, let's call it Python, Ruby, whatever, something that does have structure that you can pretty accurately reason about what's going to happen when you run it. All right, so Camp 1 says English is the way to go. Don't worry about anything else. Camp 2 says I need some symbolic representation that is non-ambiguous and accurate. And interestingly, both camps are right, because programming is not a single thing, right? You don't program your React application like you program your nuclear reactor, right? So the level of rigor required in these two ends of the spectrum is quite different. And I suspect that therefore the languages that will be used to develop these will be different as well. So I think both camps are right. where it lands is probably the usual hype curve. So we kind of like, yeah, everything is done in English. Oh, actually, we don't know how to debug this or maintain it or control it. Or every time I change one word in my application, I get a completely different result because, it's not like a continuous incremental translation. If you change the English and regenerate the app, something else may happen, right? So the space of mappings from the natural language to an application is not like nicely continuous one. When you change one word and you get to like tiny change, it may like be radical change from a tiny change in the spec. And so we're going to probably start with everything is English, then, actually, we're wrong. We need something more structured. And the truth is somewhere in the middle, and also depending on the domain, as I said, like whether it's like a UI app or like the distributed database, right?
Okay, yeah, certainly. You give the example of a nuclear power plant. If you've got like your nuclear power plant critical control shutdown code, you don't want that to be kind of, well, it's about right. I think the AI generated code was okay. That needs to be absolutely spot on.
I think many years ago, I had a conversation with someone who was working on verifying Airbus code. And he said, listen, there is a very fundamental, simple question like, how much are you willing to pay for a line of code? If you're willing to pay 30 euros, then you get Airbus level code. If you're willing to pay 3 cents per line of code, then do whatever needs to be done. It's an economical question at the end, really, because the level of trust or the level of the quality that you build in the system is at the end a question of cost as well.
Absolutely. Yeah. I guess the consequences of things going wrong for a lot of code is less than like a plane crashing or nuclear power plant exploding. So you can afford to do it a little bit cheaper. So on that subject, I'd like to talk a bit about how you go about adopting all these generative AI tools in the enterprise. So suppose your head of department, whether you're like head of data or head of software engineering, says, okay, we're going all in on AI. What do you do?
Yeah, I think what I would recommend and what we're seeing is different. We're seeing people being hesitant because of the quality aspects. So again, I think we are kind of like in code or in software engineering, we're already past the dog playing the piano. So we're past like the magic of, it can write code. We're now kind of into the question of like, does it generate quality code that I can trust? And so people are kind of hesitant to say, take the entire department, give them Tabnine and let's roll, right? Because they don't know what will the implications be. And as I said, the DDoS on the reviewer is definitely one of the concerns, right? Like it's going to just increase the pressure on our code reviewers because they have to review the AI generated code all the time, right? So, and with more being even more careful because they know the AI can generate things that are maybe not exactly what we want, right? And so what we're seeing is people are taking some part of the department, letting them try it, and then we see very quickly some expansion once they prove the value, right? So it's like very quickly because this thing is magic, right? Once you start using it, you say, oh, wait, I can do so much more. And, it's like a no-brainer. And I think as a department head, if I look at this, I say, absolutely, bring it to me today. But tell me how the code review is going to work as well. How am I not going to kind of overwork my reviewers? Tell me, can you be explicit about like what are the standards that Tabnine maintain? Can you show me the list of rules that are being enforced so I can say, oh yeah, these are the rules, or I can say, wait, there are 2 rules missing, or I can say, oh, these rules I don't care about at all, right? Which all of the above can happen. But I think really Gen AI for software development is such a no-brainer that the return is immediate. And I think at this point, I'm guessing most of our listeners are already using Gen AI. I don't think they need me to tell them to use it, right? It's been a while now. Everybody recognizes the value. I think people also recognize the potential risks and why you need code review. I think the value is like inevitable, right? It's just coming.
Okay, I like the idea that a lot of people know what they're doing. It's just going to happen. So, in terms of areas to focus on, though, like, do you start with code generation? Do you start with like, let's do documentation and get the hang of this? Do you do like low risk projects first or high value projects first? What's the order of getting it implemented?
No, I would definitely start, with, again, depending on what is the project, etc. Definitely start with new projects because the amount of code to be generated is kind of the promise, right? I can move faster. So I would definitely start with that. Also, the legacy things tend to be more subtle and more incremental changes, right? So we need to read much more code than you need to write. And so, again, it's just harder to be really successful there. Possible, but harder. Test generation is definitely one place to start because test code does not run in production, right? So you're kind of like, maybe I'm taking a risk that the test will not cover exactly what I wanted, or the tests will run longer because I have more tests and are maybe not as helpful as I wanted. But the risk is zero, right? I'm not losing anything, really. I'm not jeopardizing my production system by my junior developers accepting code from AI without understanding the implications, right? So test generation is definitely a place to start. I think, but again, code review is another place that you can get a lot of value because it reviews both code written by AI and code written by humans, right? And holds them to the same standards, which I think is also very important.
All right. So working with new projects where you're starting fresh, and then also the places where things aren't going in production directly. So testing and code review. I like it.
I would go direct to the production. I trust this well enough. I think I'm just trying to cater for people who are trying to do some gradual adoption and are risk averse, right? So.
Very nice. There's definitely a big scope, or a big spectrum from people who are like gung ho. I'll use all the latest tech for everything, and people are a bit more risk averse. I guess we're going back to the nuclear power plant example. All right, super. Okay, so just to wrap up, do you have any final advice for people wanting to make use of these AI software tools?
Resistance is futile. No, it's like it's coming. It's inevitable. Start using it today if you're not already using it.
All right. I love the Borg response there. Very nice. Okay. Thank you for your time, Eran.